We're going to set up the limit definition of a derivative using 3 different methods, and I'll talk about which ones I mostly expect you to know and recognize. So we're going to start with Hanah's method, and Hanah has 2 h's in her name, so that's how you remember that it's divided by 2h. So Hanah's method is the limit as h approaches 0 of f of x plus h minus f of x minus h over 2h. And this comes from using on f of x using 2 points, x minus h and x plus h. And then that would make this point f of x minus h. That makes this point f of x plus h. We want h to approach 0 because then that means those points get even closer together to get a more accurate slope. And then when you do rise over run, so y2 minus y1 over x2 minus x1, if you do x plus h minus x minus h, the x's cancel and you get h plus h, which is 2h. So that's where that comes from. But this one, I'm going to be honest, is not super important. I want you to be able to understand it in case it pops up on a test or whatever, but it's not the one that I typically expect my students to use constantly. But you should be able to recognize and understand that we're just like subtracting a little bit, like 0.001 for h, and then we're adding a little bit, like 0.001, and we're finding the slope between those 2 points. So that's Hanah's method. So in this particular case, since f of x is 2x cubed minus x, then f of x plus h would be 2 times x plus h cubed minus, again, anytime you're like using function composition, everywhere you see an x, you're plugging in what's inside parentheses, which in this case is x plus h, minus, and then f of x minus h. Divided by 2h. So this is kind of the more complicated limit definition of a derivative. We don't use this one a ton. Let's do a different one. So now we're going to set up using Anna's method. And Anna has an A in her name. So this is the limit as x approaches A. And the way that Anna's method works, is f of x minus f of A over x minus a. So the way that this one works is if you have your function, so we have a point x and then we have a point a. Now we want our 2 points, we want x to be really close to a. Actually, I'm going to do a here and x here. It doesn't really matter, but the point is that we want a and x to be super close together because remember, the closer 2 points are, the more accurate your slope is between them. And since we need it to be exactly correct, we need x to be as close to a as possible. So we have to use a limit. And then it's just f of x minus f of a over x minus a. So again, it's just the slope. All of these are just using the slope equation. It's just different representations of it. So in this case, f of x would be 2x cubed minus x. F of a would be 2a cubed minus a all over x minus a. Oh, I forgot my limit. You can't forget your limit. That's kind of the whole point of this, is to be a limit to definition. And so that's how you would set up using Anna's method. Now, the one that I really want you to know how to set up and solve is Hanah's method. So Hana, or I don't know, Hanah, however you want to say it, it's only got one h in it. So this is the limit as h approaches 0. And this is the one I really want you to know. This is the one that I'm going to hold you to. It's f of x plus h minus f of x over h. Okay, there's only one h in the denominator. That's why there's only one h in her name. So the way that this one works is that we've got x and we've got x plus h. And those are the 2 points that we're using. We want h to approach 0 because we want these two. So h represents the distance between these 2 points. We want that distance to be really, really close to 0 so that these 2 points are really close together. And then again, the slope is the most accurate. So, and then it's just going to be f of x plus h minus f of x over x plus h minus x. The x's cancel. So that's why our denominator is just that h. Again, in all 3 situations, it's just the slope between 2 points. Okay, and then that's going to be the limit as h approaches 0, and I do want to use my limit notation here, 2 times x plus h cubed minus x plus h minus f of x. Notice that I'm using parentheses here quite a bit because I don't want to make any silly algebraic mistakes. As you're solving the limit, you do need to have proper limit notation. So that is going to be 2 times x plus h cubed. That's x plus h. And by the way, if you know your expansions based on Pascal's triangle, you're welcome to do that as well. So minus x minus h minus 2x cubed plus x. And I just want to make sure that I am distributing properly here. Make sure you distribute those negatives. So that's going to be 2 times x cubed plus 2x squared h plus xh squared. So I distributed my x. Now I'm going to distribute my h plus x squared h plus 2xh squared plus h cubed minus, okay, I'm going to go ahead and cancel these now, minus h minus 2x cubed all over h. That's the limit as h approaches 0. Just practicing our algebra skills here. 2x cubed plus, okay, I'm going to go ahead and start combining these. 2x squared h plus x squared h is 3x squared h times 2 is 6x squared h. And then xh squared plus 2xh squared is 3xh squared times 2 is 6xh squared plus 2h cubed minus h minus 2x cubed. This cancels with this. And now we're going to divide everything by h. So I get 6x squared plus 6xh plus 2h squared minus 1. Now I can plug in h is 0, which is 6x squared minus 1. So that is the using the limit definition of a derivative. And again, this is the one I really want you to know. This is the one I'm going to hold you to. So let's use the power rule and double check that our answer was correct. So f of x is 2x cubed minus x. So let's go ahead and use the power rule. F prime is equal to 3 times 2 is 6. X 3 minus 2 is 2 minus 1. So it checks out. Power rule tells me that I did this properly. And again, you will be tested on solving a limit definition of a derivative by hand, so make sure you can do this. All right, and then we are going to graph f of x plus h minus f of x over h for h is 0.01. So that's going to be 2 times x plus 0.01 cubed minus x plus 0.01 minus 2x cubed minus x over 0.01. So all I'm doing is I'm plugging in a number really close, and then I'm going to see what happens. That is going to be 2 parentheses x plus 0.01 cubed plus, oh, did I have the equation correct? No, minus x plus 0.01 parentheses. Okay, so that's f of x plus h minus f of x. So 2x cubed minus x. And notice I need a lot of parentheses for this. Divided by 0.01. Let's go ahead and graph that. And remember the answer, let's go ahead and just graph this and the answer. The answer was 6x squared minus 1. And let's see if those two things graph very similar to each other. So you can see, because mine is color-coded, that blue and that red line are very close. You can, do I press enter on this? Yeah. So I just press entered on the equal sign. So now I'm not going to be able to see the blue one at all. So I just have my red one. Okay, let's see the blue one and not the red one. And you can see they're in the same location. So yes, my answers line up. That if you plug in f of x plus h minus f of x over h, and you plug in h is very, very close to 0, then that gives you the correct derivative.